Procedural games like Minecraft, Terraria or Factorio all have a couple of things in common. One of them is Biomes, so let's work on that. I'll be using the tool I made last time to build the world generator. You can watch my video about it later if you're interested in that. In the beginning there was nothing, so I smashed the ground a few times and tweaked the values for the default biome that will be the flatland. Placed the character for scale, realized it wasn't flat at all and so I smashed it again. Having now an empty canvas, I switched to work on some second biome, which gonna be a hilly terrain. And
let me explain to you how biomes work. You got this nice looking bumps and this nice looking bumps. You know what you need right now? That's right, fairly nice. Clamp that shit, plug it into the blend node, bada boom, smooth blending on the mask that we just made.
And then I tweaked the fall off a little bit for that smooth look. Next in line are lakes, which are basically a hilly terrain upside down and a very steep fall off. Mountains were a little bit tricky to implement. Right now they are just weird looking blobs, not really mountainy. That can be easily explained by their fall off to the ground. Look at the side of this bump and then at this picture. Mine are way too round, whilst this one looks almost pinched upwards. Let's look at one of the mountain ranges I found and at its fall off mask. First I want to get rid of those hard edges at the bottom, so let's smoothen them out. Now when I pinch them, this makes a lot of a difference. And smoothen them again to avoid this hard transition at the top. I also subtracted the mountain mask from the hilly terrain mask to avoid some of the noise that it generates at the top of the peaks. Later on I've experimented with rivers, but they are out of the picture as all I could get was spaghetti. Spaghetti! Here is the end result. You can see the mountain range in the middle, some of the hilly terrain near the plains, and a lake near the corner. And this is how it looks like in 1:1 scale. Wowee. By the way, the average distance between those debug points is around 40 meters, so you could fit average me around 23 times between them, meaning that this entire chunk is around 12 km long, or around 7 miles for those unit impaired out there, and it would take around 3 hours on foot to cross, or that it would fit around 6,900 people. Nice. For now it's all for the hate map and it's time to make this bad boy go solid. Any mesh in the game that you see is made out of triangles that consist out of group of vertices. So if I want to build a mesh, I need to generate a lot of those points and then connect all of them together. After a little bit of research, I found out that there is already a framework for that in Unreal 5 called geometry scripting. Unfortunately for now there is little to no information about this framework on the web, so all the information I needed I had to get from the source code or the absolute chat Ryan Schmidt on YouTube. I've enabled this plugin and now I just need to figure out how to make the things I wanted to do. Hey yo, write that down! But alas, behold, the cube! What the fuck is that? What the fuck is this? What the fuck are you? Yeah, seems like figuring out which vertex is related to which triangle is gonna be a bit tricky. But it's getting somewhere, I think. The good news is, it works when I make it a square. The bad news is, why? This looks right, and this looks right, and wait a minute. Oh, you little bastard. That explains why it was working only when the columns and rows numbers were the same, because it was the only time when it was using the right number. Next in line, smooth lighting. I'm not that familiar with the topic, so please bear with me for a moment. Each vertex and triangle has some information about the direction they are facing in. That's what we call a normal vector. This vector then tells the light how to bounce off the surface at any given position. If we blend the value of those two normal vectors between them based on their distance to each other, that's how we're getting the smooth lighting. Adding normals computation at the end of mesh generation did just that for me. Although I still don't know why it's doing this sometimes. And that's that. The procedurally generated landscape gray blob. I don't know yet what I'll be using this landscape for, but I really like the debug point cloud that I was using. So maybe some kind of device to show the map around the player? Does it come the time? to make a shader for my entire world. The shader itself went through a bunch of iterations and experiments. At first it was a wireframe, then elevation lines that we are familiar with from real-world maps. I've also tried replicating the points code, but it really didn't turn out that well. After playing for a bit, I made this cool looking transition and decided to make a hologram shader around it. It was a lot of trial and error, but it's done. Here is the final result when we look at it from afar. And here's how it looks like when we get up close. But let's take a step back and check how it works. Everything starts from the noise. This basically gives us a value between 0 and 1 recolored to grayscale. Take the current game time, multiplied by some value, now I've got a number changing with some speed. Add this value to the pixel's height position to offset it over time. Recombine it with the XY coordinates of the pixel to get its XYZ position, and plug it back into the noise function. This one does the same thing as the one before, but with different speed. Here I add the noise value to the pixel's height position to further offset it down, and here is the modulo which allows me to define the thickness of those scan lines. This node inverts the color, and this one just amplifies it. It's basically just a trial and error at this point to get the best result. I don't think I need this one. This one is a bit complex, but I'm basically using it to define the thickness of those black bars and to smoothen out those white areas. Not really important. Fresnel. This one basically tells us how much the pixel is not looking at the camera, which is great for those sideways parts of the model, for that hologram highlight. Now append the noisy noise to simulate the random static. Use the lerp node to change the white values into this color and the black values into this color. Then increase the intensity of the color for some added glow. Here I made some math defining the pixel's transparency. And here is a glitch effect that you might notice is a bit overcomplicated, so let's skip that for now. The hologram's done. This room we are in right now though is a bit boring, so let's work on something better to place that bad boy in. In the meantime, it's time to talk about the elephant in the room. Generating a mesh with high enough complexity takes time. A long time. Imagine you're trying to move the hologram view a few units in some direction. Right now I have to regenerate the entire thing, which might take off upwards towards a minute, freezing the main thread in the meantime. Imagine a half a minute long stutter every time you take a step in a game. That's a no-no. The room is done though. Fortunately, there is an easy solution for those stutters. Just split the mesh and generate it using bite-sized chunks. As I'm still very much prototyping, all of the management logic is gonna stay in blueprints for now. First try didn't go that well. I mean, there is definitely a chunk there, but why only one? Second try went a bit better. I mean, there are definitely different chunks there, but what's up with their rotation? Or maybe order? Yeah, that was definitely an order issue. On to the next problem. The chunks are too small. Increase the chunk size. The last few chunks are generated before the first one. What? Change the order. Now they are not generating at all. What? Right, let's check that we are the last column after we iterate that column. Now let's attach the proper material and that looks good. It's not transparent. Render custom depth pass. They are overlapping. Decrease the chunk size a little bit. Chunks are done. Here is the entire room filling slowly chunk by chunk. Stop! Yeah, turning off the shaders showed that there is an issue of generating those normal vectors at the seams of the chunks. I will definitely fix that later. Postscriptum. Under the previous video, someone mentioned to check out the Realtime Mesh component for generating procedural meshes at runtime. And gotta say, it has one hell of a complicated coding standard. Overall, I've managed to replicate the same results as with geometry scripting of generating the landscape using chunks. And unfortunately, there weren't any noticeable performance gains, which means I'm going to stay with my previous solution. Thank you for the recommendation though. Congrats, you've made it to the end. If you think I deserve the grace of the almighty algorithm, then please like, dislike, comment or subscribe. I dare you to do all 4 of them. Next time, I hope to work on some atmosphere and maybe some of the first gameplay. Thank you for watching, and I hope to see you in the next one.
Yes.